Alright, today we'll be talking about finding infinite limits in AP Calculus. Okay, infinite limits is just, it's not a limit where it does not exist. If you remember, we talked about finding limits analytically. We talked about possibly getting something like that, but infinite limits do exist. Okay, so best way to do this is to kind of look at just working with the actual graph. Okay, so let's take a look at one. Let me do the limit as x approaches 0 of the function 1 over x. Okay. Alright, so we take a look at it from the left hand to the right hand side. Okay, and so I'm going to go to Desmos, if I can find that button. There we go. Okay. Alright, so 1 divided by x. Oh my gosh, No, I didn't do that. I thought I did 1. Okay, so here's it is. Okay, so as x approaches 0, okay, if I zoom out and I look at it, x is getting a lot bigger, but I can't really see it exact. So I'm going to look at the table, and this is just very helpful to look at the table. Okay, I'm going to go up here, press enter, and let's go 10. Okay, so I get 0.1. So, oh, that's x. I want to approach 0, so let's go 0.1. Okay, so that's 10, so that helps. Okay, 0.01. It's 100. Okay, let's make 0 even smaller, or x even smaller. Okay, that's 1,000. All right, let's make it really large. Let's amp this up. It's 100,000. As you can see, as x gets closer and closer to 0, we're going to get to something really ridiculously small. So let's go. Now we're at 1 billion. So this is approaching infinity from this side. Okay, now if I approach it from the other side, 0, okay, as you can see, it's undefined on my table. Okay, as I approach it from the other side, yeah, let's get rid of all these. Okay, so that's approaching it. So this is 0. Okay, now let's go negative 0.1. Okay, let's go another one. Let's go negative 0.01. Okay, and as you can see, the closer and closer I get to 0, oops. Okay, let's go enter. Negative 0.001. Okay, and as you can see, as it gets closer and closer to it, negative 0.0001. As you can see, probably the closer and closer I get to it, okay, I'm going to get closer to negative infinity, the closer I get to 0 here. Okay, alright, so looking at the table, I'm getting closer to infinity, and as you can see, my graph is tending towards negative infinity, and my graph is tending towards positive infinity going that way. So because of that, I would say the left-hand and the right-hand side do not exist. They do not equal the same thing, so this would be a do not exist. Okay, so that's an example of a graph that does not have a infinite function like that. However, if I change something a little bit, like limit as x approaches 0 and my function is 6 over x squared, okay, and this is important, you have to square the x because otherwise your graph's not going to look like this. Okay, so let's go up and x out of this. Okay, so 6 divided by x squared. Okay, as you can see, as I approach 0 from both sides, look at that. They're both heading towards the same number. And if you remember the definition for the left-handed and the right-handed side limits, I'm approaching the same number and it does exist. Well, infinite does exist. Alt 236. Okay, so my result would actually, well, let's make that more specific. Let's make that positive infinity. There we go. Okay. Alright, so that's the infinite type of limit. Now if I put a negative on there, obviously I would flip it upside down and it would just be funky like that, okay? But you have to have both numbers approach it. Okay, alright, so real fast, the function f of x will have a vertical asymptote at x equals a if we have any of the following limits at x equals a. In other words, the limit as x approaches the number from the left side is positive or negative infinity. Well, we already kind of knew that. We could graph it and just work with it. This is just analytical work type stuff. So just so you know, it's just funky looking like that. Now, if we did do something that was like this, let's do limit as x approaches 0 from the right side, and I'm going to connotate it by a plus sign. Okay, so that just means the right side of ln of x. Because if you remember, you can't put a negative number into a natural log. Okay. Alright, so if we take a look at it, if we go back to our graph, okay, so let's x out, let's go natural log of x. Okay, as we approach 0 from this side, we're going to get negative infinity. There is no right-hand side because you're not going to have it, so that just means that the limit as we approach from the right-hand side is just going to be negative. I'm using my alt codes. If you haven't downloaded that document, you probably should. Where is that? Oh, there it is. Alt 236. There you go. And so everything's just all set up like this, so you guys can actually type out and do some actual stuff here. Okay. All right. Now another graph that does pop up on people is tangent. It doesn't approach certain numbers. It doesn't approach the same infinite on any of the spots, so just be careful when you're looking at tangent and approaching any of the, I think it's pi halves. Just off the top of my head. Yeah, it's pi halves, multiples of pi halves, odd multiples of pi halves. Okay, so some things we've learned real fast. No, we just take a look at your graph. Look at the graph, use that to help, and just understand a rough graph of what's going on. And plus, if you can plug in a number that's really big in here, here's the thing. For your AP test, you guys, you need to be able to do a table of values and see what's happening. So you need to put in an x and an f of x table. Alright, and be able to do that. So you need to be able to look at this and be able to plug in values and go, okay, what is it approaching? And everything, okay? Alright, so your table of values needs to be immaculate, but for right now you can use your calculator to help out, but just realize in the AP test you're not going to be able to do that. Thank you guys very much and have a great day. Bye.